everyone. I'm going to be discussing the optics of lava, and let's get started. So the reason I'm going to be skipping over these slides is because I want to discuss the model sheets and the good and bad examples. But if you can, pausing through these would be really vital because there is a lot of good information on here that can help you out even more. But this is a lot of reading and I don't want to go through it, so let's just get straight to the point and discuss the model sheets. So the volcano type or lava type I'm going to be discussing is mafic lava. And there are three types, but mafic is the most important one and it's the one that everyone thinks of when they think of the word lava. There's also felsic and intermediate, but those can be discussed in the earlier slides and I'm not discussing those at the moment. And mafic has a runny quality to it like honey, and it has a lower viscosity and it's high in fluidity because of its lower silica content. It contains oxygen and silicon in a high amount, and it causes it to be very quickly moving and not in comparison to water, though. It doesn't move like water. Bear that in mind. Usually the flows are very large and in size. They take up quite a large amount of area. And when eruptions in mafic volcanoes happen, they're not very explosive and not a lot of smoke is produced. Anyway, there are three types of flows. There's Pahoi, A'a, and Pillow. Pahoi and A'a usually are the only two to form actual flows, as you can see here. Pillow forms in underwater volcanoes due to the pressure. And all Pahoi, especially Pahoi, tends to form flat-like sheet bodies. As you can see, it's very flat and low to the ground. A'a is a little bit more raised, and Pillow is a weird formation under the water. And all three of these are oceanic volcanoes, so in areas like Hawaii, Iceland, and I didn't list it, but the Ring of Fire. And right here is very important. Lava's coloration is because of its temperature. So this scale right here is a basic kind of gist version of what its temperature is. So if you can memorize this and maybe take it in accordance of what your image's temperature is, if you consider that, then this is really helpful for doing lava correctly. Because in a lot of examples, the lava is done incorrectly because all the temperatures are off. Now, these are the flows of mafic lava. I'm not going to be discussing these because the information is already in front of you, but please read this information. It's very important and hopefully you get to it. Lava actions. These are things lava can do. Fountain is when lava explodes out of the volcano, and when it does, it forms a triangular shape. And within that triangular shape are even smaller triangles, so fractals. Jeff probably was really happy I said that. Deltas are when lava enters a body of water, and it is usually shown and marked by a series of steam, plums, and bubbles. And what happens when this happens is cinders and glass, which is liminupele, forms from these deltas, and that's what actually creates landmass. And lakes are when lava is contained in an area that's a depression or a crater or in a puddle, and this is usually inside the volcano and in areas like around the base. And in areas like this, there is wholly and partially molten areas as well as cooled areas, as you can see here in these images. And these cooled areas usually have geometric sharp edges to them. And bubbles can appear in these areas because when lava is moving, it's releasing air from it. But when it's in a contained area like this, the air has nowhere to travel but up, hence bubbles form. And fall collision, which is right here, happens when lava collides or falls on an object. And it'll produce a glow on these objects, and when heat goes against these objects, it will heat back to one of its hottest forms. And on the color temperature scale, it's usually 2 above it. So both these flows are orangey and red in color. So the color on the spectrum of what these light collisions would be yellow or yellow-orange, as you can see here. Now here are the good and bad examples. Now here's the best example I found so far. There's a lot more, but for the sake of speed, gonna cover this one. What they did right was that they had the collisions accurate. Because of the coloration of this lava, which is orange, red, becoming dark browny red, it would have yellow streaks on the edges. Areas like here are beginning to cool, which is accurate. Lava is not a constant temperature. It will cool in areas and it will stay hotter in other areas. And there's heat coming from it, which is really nice. The fact that they considered that's in a cavern, heat's going to be rising and you're going to see it. And my only nitpickiness really about it is that this guy right here would be dying of a heat stroke, or that's the least of his worries. Now for the bad examples. I can rant about these ones, but I'll get into it quickly. This one right here, this one is a temperatured mess. Like I said previously, that temperature is actually one of the main issues. And right here, this area is cooled, but is beginning to cool. So why would it have a streak of yellow? If it was cooling this much, its streak would be at least red. And areas like this, the texturing's off and the coloration is wrong. So this one has textures that are incorrect and temperature that is incorrect, and I believe the perspective's off actually too. This one, Pillow does not have flows underwater. As soon as it explodes out of the volcano, it's going to immediately start crusting over. And so this should not be here, and because of this coloration, there should be a lot more steam plumes. This entire composition of anything could be covered up. Lava is not water, so it does not have the same properties as water. This guy right here would have the streaks of heat on him. There would not be ripples. Pahoe can look like it has ripples, but it's actually pushing against itself to make it look like it has ripples. Water, I don't know what it does, but it doesn't look like ripples. And also, you would not see reflections. Lava is extremely thick. You would not see anything like that within it. Also, lava emits its own light source, so you wouldn't see this anyway, nor would you see shadows casting on the rock behind this thing. And also, if this was like this hot, it would be emitting a much brighter glow on these rocks. As for this one, lava does not have a pinkish hue in its color spectrum, so that is incorrect. I do commemorate that they did get the triangular patterns of the fountains correctly, but areas like these should be cooled. It doesn't seem like it's being any activity going on there, so it should be cooling over. And yeah. Here is the famous volcano scene in Lord of the Rings: Return of the King. This is when Sam and Frodo have just gotten rid of, what's his name? The ring guy, the creepy imp thing. I forgot what his name is. Anyway, he just fell into the volcano, and it's erupting and all that stuff, as you can see. And what I'm going to say right now is what they did do right is that the lava looks like lava. They actually took into consideration in the big budget they had that they could actually make it look like lava. And the temperatures are accurate, actually, for what is going on in the situation. And the fountains, right here, as you actually can see, are triangular. So kudos on that. What they did wrong, however, is something that a lot of movies do, and I think it's for the sake, like explosions, people love to exaggerate volcanoes for a cool factor or an impending doom situation, kind of like this. In nature, lava will not have this much smoke, or any smoke at all, with a lava flow volcano. It does not happen. Smoke like this, the New Ardente and Tephra, is produced with felsic and intermediate volcanoes. Lava, specifically like this, is only formed with mafic. So I get probably why they did it, because this is such an ominous situation. This is more terrifying than this being gone or this being gone. So I get why they did it. And also, the lava's animation when it's chasing Sam and Frodo out of the cave is moving way too fast. It's moving much too much like water. And I think it's more for the sake that lava is relatively slow. You can outrun it. Even though it does move somewhat fast, you still can outrun it. So nothing super dangerous of something you can outrun. So if you make it super fast and hardly can barely outrun it, then it's a little bit more impending and dangerous. So I get probably the reason why they animated it this way. So let's watch. So hopefully you understood what I meant with these comments here at the bottom, and if you want to go back and watch it, you can. Go for it. And this one. Much hate for this film and much hate for these prequel series in general, and honestly, after studying so much about lava, this planet in general just upsets me to my core. And so I'm going to get this as brief as possible because I could rant about this. What is done right is nothing. Nothing is done right in this. There's actually a lot of things done wrong, and what I have listed is actually barely anything I could cover. What is done wrong, though, is right off the bat is it moves way too much like water, like way too much. This waterfall will even be producing a mist, and lava does not produce mist. That's a property water has. The textures of the lava are inaccurate. The temperature's off. Areas that are cooled are on areas that are actively moving. When lava is flowing, especially at this speed, the way they sped it up, it doesn't have time to cool. Lava is slow, and when it's slow, it has time to cool. But when it's moving this fast, there's no time for it to. So areas you'll see that are cooling over, just it doesn't scientifically happen like that. Also, like I previously said, lava, when it's moving, is releasing air. When fountains are coming out of the actively moving flows, it doesn't happen like that. It needs to be within a lake. I don't know why the air is deciding to go up randomly too. And there's so many things wrong with this thing. I'll just let you watch it and you can see why. And they should not be alive. This planet is uninhabitable. It's like an Earth's core. In summary, the lava that everyone thinks of is mafic. Mafic is the one that produces actual lava flows. Felsic Intermediate produces tephra and Nua Ardente. And there is a balance. You probably will hear about it in Jeffrey Liu's presentation, but there are fractals in everything. And lava's, volcanoes' fractals is that there's a balance. If there's a lot of lava flow, there's barely any smoke. If there's a lot of smoke, barely any lava. Also, when it comes to lighting, bear in mind lava is its own light source. You can totally use that to your advantage. And remember, lava is not water, nor is it a liquid. It is a molten rock. Rock is still solid. And if you ever wish to paint and draw lava accurately, reference some photographs or videos or visit an active flow site. It's truly the best way you can do it. And for animators, if you ever wish to effectively animate lava, you can create an easy mock-up version with honey. And the scientific community uses it, so why can't you? I guarantee there's a bottle of honey in your kitchen. And so I would like to thank all of you for watching this. I hope you learned something, and you can check out these cool videos. And I hope you enjoyed this presentation, and thanks for watching.